Hello everyone, welcome back. This is Engineer Sen Mosapi. So in this video, we'll be looking at how to find the tension in cables necessary to support an object. Alright, so before we begin, do not forget to like and subscribe to the channel. Alright, so let's begin. So I'll explain this with an example that will help you to understand the concepts behind it. So the example says, determine the tension in the cable BA. Let me change my color to red. BA, this is BA, and BC, this is BC to support the 60 kg cylinder. This is our cylinder. Now, basically, to go about solving this, the first thing we're supposed to do is to draw a free body diagram. So our free body diagram will be in this manner. So the first thing we're supposed to do is to draw a coordinate system. So let's say we have our y-axis and our x-axis. So this is our x and this is our y. So I'll start by first representing the main point. Always get the main point, the middle point where all these forces are coming from. Remember, most of the examples I'll be looking at are going to be coming from coplanar force type of systems. So all these forces are coming from one point. This is this point here. So that's my point of interest. So the first force I represent is my weight force, which is downward. So this is the weight of the cylinder being equal to mg, and the mass has been given to be 60. So I'll say 60 times gravity, which is 9.81, and basically this will give us 588.6 newtons. Other than that, you can also show the tensions in the ropes that we have. So we have the tension acting this side at an angle of 45. So we have this tension at an angle of 45 degrees. So this is point B. So this tension from B to that point, which is C, this is going to be tension BC. Then we also have the tension in this direction. Now this tension is given a 3-4-5 triangle representation. So we have the 3-4-5 triangle. 3, 4, 5. So this tension is headed to A. So this is tension BA. Now that we have drawn our free body diagram, we need to understand that the conditions that must be met for a body to be in equilibrium is that the sum of all forces should be equivalent to 0. Since this is static, it implies that even if we had to show the kinetic diagram, there wouldn't be any motion. So this side will end up having a 0. So the sum of all forces on the free body diagram will be equal to nothing on the kinetic diagram. But since it's static, there's no need of us to be even including the kinetic diagram. So I'll just erase it. So we know that the condition is that the sum of all forces acting either in the x or y should be equal to 0. So we should satisfy that condition. Now, once you have done that, the next thing we can do is to resolve all these forces into its x and y components. So let us resolve the forces. Resolve each force or vector. So I'll start with the weight. Now the weight is only acting in the negative y direction, so it has nothing in the I. So 0 in the I, minus 588.6 in the J. So that is our weight result. Then we can look at tension BC. So what is the component, or what are the components of tension BC? Now if I resolve tension BC is at an angle. It's not acting along a particular axis, but rather it's at an angle. So I have to resolve it with respect to the 45. So I have to go in this direction. So I'll move TB cos 45. Then I'll go upwards, and this will be TBC sine 45. So I know that my x component will be TBC cos 45 in the I plus TBC sine 45 in the j. And that is our resolved form. Then we can look at the tension at BA. Now, tension at BA, should be mindful of this. We're having the 3, 4, 5 triangle. So if I had to draw the 3, 4, 5 triangle somewhere, let's say here. So we have 3, 3, 4, 5. This is the 90 degrees. If at all we had, look at that. Let me show you what I mean. Now, this triangle can give us the angle there, theta. Now, there are two ways you can do this. You can find the angle theta, then resolve the components, or you can just use the 3, 4, 5 triangle. In the sense that we know that this triangle, this is our theta representing the side. This is the opposite, this is the hypotenuse, and this is the adjacent. So using the trig ratio SOHCAHTOA, remember, this is in 2 dimensions. So our main interest is simply just the x and the y. So we need the sine and the cos. So if at all I had to look for sine theta according to the 3, 4, 5 triangle is opposite over hypotenuse. And the opposite is 3, and the hypotenuse is simply 5. Then cos theta will simply be the adjacent over the hypotenuse, which will be 4 over 5. So I can use these to resolve my forces. Therefore, I'll have TBA cos theta. Then in that direction, I have TBA sine theta. Just like that. So we're going to have, since TBA cos theta is going in a negative direction, we'll have negative TBA cos theta, then plus TBA sine theta. Therefore, TBA can also be written as negative TBA. Now cos theta is represented as this here. So it's going to be 4 over 5 plus TBA sine theta, this is sine theta, is basically 3 over 5. So I'll show it as 3 over 5 like that. And this as well would be in newtons, just like this other one. Now that we have resolved these forces into their components, we can now meet the condition that satisfies equilibrium. Now, for those of you who are having, or let's say facing challenges resolving these forces into their components, you can go back to the playlist and look for a video that I made where I was resolving certain examples where I had systems into their components. All right, let's continue. Now, once we do that, we need to meet the condition. The condition states that, so meet the condition. The condition states that the sum of the forces acting in any axis should be equivalent to 0. So let us sum up all the forces. So the sum of all forces acting in the x, let's start with the x-axis, should give us what? 0. Be mindful about that. So looking at the forces we have in the x, we can start with any of the forces that have been resolved because we have resolved our forces here. So let's start with the weight force. Let's get any component from this guy, that guy, and the other guy. So by doing so, we start with the weight. What's the component in the I, which is the x, which for the weight we're having 0. So 0 plus, what is the component of TBC in the x-axis, which is the I? That is TBC cos 45. Now, what is the x component in TBA? Because we're summing them up. We're having minus. So it's going to be minus TBA times 4 over 5. And the sum of all forces acting in the x-axis should equal to what? 0. Then we can basically just clean this up. Now, be mindful, we'll have TBA cos 45. Then when this goes the other side, we'll have is equal to 4 over 5 TB, sorry, this is supposed to be BC, TBC, then this is TBA. Sorry about that. So it means that TBC cos 45 is equal to 4 over 5 TBA. So we'll have that. Now we need to make either TBC or TBA the subject of the formula. So in my case, I'll make TBC the subject of the formula by dividing both sides by cos what? 45. By doing so, I'll be dividing both ends by 45, and I have TBC being equal to 4 over 5 divided by cos 45 will give us a value of 1.1313708.5 TBA. Now, in most cases, you end up having a lot of lengthy decimal fractions. So in most cases, I will specify depending with the person who has prepared the question for you. But it's quite important to remember that in most cases, most people have to put their answers correctly through significant figures, or they can just get the entire thing. It's okay. So I'll just get the entire thing, but if you want, you can round off to 2 decimal places to get through significant figures and use that. The answers will still come out the same. They'll always come out the same. It's just that the accuracy of the value you get will differ, but if you round off to a whole number, you'd find that you'll be close to the exact value. So use 3 significant figures to get a precise answer. But if you're not comfortable with that, you can always just get the entire thing. So I'll get the entire thing. TBC is equal to 1.1313708.5 TBA. And this will be my equation number 1. So I've summed up all the forces in the X, and I have that. Now, it's not in all cases that most of the videos I'll be doing, I'll be writing everything. No. Mostly, I also love to put my answers to 3 significant figures. It's just that I feel like just writing everything today. Alright, so let me erase the top portion so that I can use the space. Alright, so going back to my magic pen. Now we need to now solve condition 2. The sum of the all forces that we have in the y should give us 0. So the sum of all the forces acting in the y should give us 0. So getting the y forces, first with the weight force, we're having minus 588, sorry about that, 588.6 plus the j component, which is the y component for TBC, which is plus TBC sine 45, then plus the y component of TBA, which is the j component, to be precise. It's going to be TBA, then 3 over 5, like that, because you know it's sine theta, and sine theta according to the 3, 4, 5 triangle is giving us 3 over 5, and this should give us nothing but 0. Alright, so I can also write this and let the variables be on one side, so I can do this by saying, okay, I'm having TBC sine 45 plus TBA times 3 over 5 is equal to, I can take the weight force and take it the other side, and I'll have positive 588.6. Now remember, I already have the value of TBC, so I can get that value and plug it where TBC is. So by doing so, I'll be having a very lengthy value, which is 1.1. Okay, I'm going to get it to 3. Okay, that's fine. I just get everything so that I don't confuse you. 13708.5. Sorry, it should be then TBA, then times sine 45 plus TBA times 3 over 5 is equal to 5.88.6, like that. Then all I'm supposed to do is to multiply this. Now, even if I got 1.13, then I multiply by sine 45, I'll still get the same value that I want. But in this case, since I had to make equation number 1 to have the entire thing here, I'll just do the same. So if I multiply by sine 45, I end up having 0.8 TBA plus, now I'm having 3 over 5. Now 3 over 5 is basically the same as 0.6, so I can say plus 0.6 TBA, and this should equal to 5.8. Sorry, is it 5.88? No, it's supposed to be 588. 588.6. Yeah, sorry about that glitch. So that's going to be 588.6. Now if I add 0.8 to 0.6, I'll basically have 1.4 TBA being equal to 588.6. Dividing both ends by 1.4, even the other side 1.4, we'll get TBA to be equal to 420.42857114, and this will be in newtons. Now I need you to see this clearly. If at all let's say I want to round off, I know that my TBA, if I round off to like 2 decimal places, if it was 3 significant figures, I would have just written as 420. But if I say rounding off to 2 decimal places, I would get maybe like something like 420.43 newtons, provided that I was told to leave my answer to 2 decimal places. But if I was told to leave my answer correct to 3 significant figures, my answer would have been 420. Now that I have my value of TBA here, I can use this value, plug back where I need it the most, which is in TBC. I know that from equation number 1, I know that TBC is equal to 1.1313708.5, then TBA. Now I already know the value of TBA. Now in most cases, when you're substituting, in this case, well, let's say you find one value, always get the entire figure to get a value that is close. Mostly I prefer rounding off at my final answer, but it depends with what you want. But TBA is found to be 420.4285714. So if I compute this, TBC is going to be equal to, multiplying that's going to give us 475.6606302 newtons. Therefore, TBC is going to be, if I round off to 2 decimal places, 475.66, like that. This will be in newtons, and this will be my final answer. Now, in most cases, if at all I had to round off with three significant figures, my answer would have been 476 newtons. So I really don't want you to have that confusion when it comes to rounding off numbers. I hope most of you know how to round off numbers and not find significant figures. If at all you don't, there's a video that I've made under significant figures, rounding off, and everything on that aspect. So kindly watch it so that you don't get confused as we do more and more examples. Alright, so thanks for watching. If you have queries, you can reach me on WhatsApp on the line 077 149 5252. Remember, slow progress is better than no progress, and let's strategize before becoming a statistic. Let's try and push for that A+.